Welcome to this video. In this video we'll see a question based on projection of solids. Question is: a hexagonal prism base of edge 25 mm and height 60 mm is resting on one of its base edges with axis inclined at 30 degrees with HP and 40 degrees with VP. The nearest point of the solid is at a distance of 10 mm away from VP. Draw the projections. So first you draw the reference line, and since in this case since your object is resting on edge of its base, so that edge should come on the right side like this in top view. So this is the top view of the initial position. So first you draw a line at perpendicular like this, perpendicular to the axis like this, having length 20 mm. Now you can construct a hexagon. Hexagon included angle is 120 degrees. So from here you can take 120 degrees like this and draw that line at 20 mm. Again 120 degrees like this and draw that line at 20 mm. So in that way you can construct a hexagon. Draw the hexagon and do the dimensioning. Now since it's a prism, you have top face and base. So top face points we will name it as A, B, C, D, E, F, and base points as 1, 2, 3, 4, 5, 6. So base is invisible in top view. So those points will be invisible in top view. So those points we will be writing inside the bracket. Now first you project all these points to the reference line, and since the height of the object is 60 mm, you mark height of the object 60 mm like this and draw that front view like this. Now here these points, these are the top face points and these are the base points. Top face points will be, you have to consider the points which are coming outside the bracket. So this point will be here. This diagram you want to see from base, from here. Okay, observer is here, and for marking the front view, you consider this observe this point from base, from here. So first B and A. So for drawing the top face points, you have to consider the points which are coming outside bracket. So first B and A. So this point will be B dash A dash. Then here C and F. So this is C dash F dash, and this is D and E. So this is D dash E dash. Similarly, to mark the base points, you have to consider the points coming inside the bracket. So here it is 2 and 1. So it is 2 dash 1 dash. 3 and 6. So 3 dash 6 dash, and 4 and 5. So this is 4 dash 5 dash. To the dimensioning 60 mm. Now since the object is inclined at 40 degrees with 30 degrees with HP, so first you mark a point here, and having a length of 60 mm, you draw a line like this. A line of length 60 mm at 30 degrees you draw like this. Now this angle is 90 degrees. So draw this line, measure this length, and draw that line perpendicular from here like this, from perpendicular to this line. This line perpendicular to that line, you draw a line like this and having a length of this much. So you can draw that line. Now you can complete that rectangle like this, mark the center point here and here and connect that. You can draw the front view, name those points with suffix 1, same points with suffix 1, B1 dash, A1 dash, C1 dash, F1 dash, D1 dash, E1 dash, and here base points as 2 dash, 1 dash, 3 dash, 6 dash, 4 dash, and 5 dash. Now to get the fourth diagram, the top view of the tilted position after clearing the horizontal plane angle, draw the projection lines from here like this, and draw vertical lines from each point to the corresponding line, from 1 to 1, 2 to 2, 3 to 3 in that way. Here A to A, B to B, in that way you can get 6 points here and 6 points here. Connect those points and get the shape of a hexagon like this. So here in this point, in this face, you have some lines will be invisible. To find those lines, since this is the top face will be visible in this diagram. So mark those top face as visible by using dark continuous lines. Then draw the border of the object like this. Now you consider the first diagram. In this diagram, the top and extreme upper and lower points, that is 6 and 3, which are coming inside bracket. So 6 and 3, you consider 6 and 3. So since the object is tilted towards right, you consider the point which are coming inside bracket on the right side. That means 4 and 5. Upper and lower extreme right side bracket, which are coming the points which are coming inside bracket. So 4 and 5. So all the point lines to the point 4 and 5 will be invisible. So you want to mark 6, 5, 6, 6, 4 and 4, 3, and also 4D and 5E will be invisible lines. So and the remaining two lines 1A and 2B will be visible. So you want to mark 1 and A1 as visible and 2 and B1 as visible. So that means this line this line, that is 5e and 4d, a part of that is visible. I mean, since this 1a is visible, so you want to mark that line as this much as visible, and remaining portion only dotted line. So the line 5e, only this much portion you have to use dotted line, and 4d, only this much portion you want to use dotted line. So remaining lines 6.5, 5.4 and 4.3 will be invisible in top view after tilting. Now draw the cross diagonals. You can get this axis here also, this face also, and this face. You draw cross diagonals, you can get the axis points. You connect that by using chain line, that is the axis. Now since the object is, it is given that the nearest point, the object is inclined at 40 degrees with VP, and the nearest point, the axis is inclined at 40 degrees with VP, and the nearest point of the solid is at a distance of 10 mm away from the VP. So first you mark a line at 10 mm away like this. Now draw the 60 degree line like this, 60 mm, 40 degree line like this, having a length of 60 mm. 40 degrees at 60 mm. From somewhere here you mark 60 mm with at 40 degrees. Now since here in this case the axis is having two inclinations, horizontal plane inclination and vertical plane inclination, that means you want to find the apparent inclination. To find the apparent inclination, from here you draw a line 60 degrees, like 60 mm like this at 40 degrees, and then from there you draw the locus of that point here like this. Then from this point you want to cut the axis length in this fourth diagram, that is measure this dimension, distance from here to here, and cut that distance, that is you are getting that as 52 mm. So from here you cut 52 mm to that line. So first you draw a 40 degree line at 60 mm, that is 40 degree line at 60 mm like this, and through this point you draw the locus of that point. Now measure this distance from here to here, you are getting it as 52 mm. So from here you mark 52 mm like this, so you will get the apparent inclination as 48 degrees. So since the object is inclined at both at horizontal plane and vertical plane, the apparent inclination you are getting as 48 degrees. So you want to draw this, you want to copy this hexagon at inclined at 48 degrees like this. Now to draw the line at 48 degrees, now you consider this line, this new line, 48 degree line. Now it is given that the nearest point is at a distance of 10 mm away from VP. So once it is turned like this, the nearest point nearest point to the horizontal vertical plane will be 6, the point 6. So you want to consider this distance from here to here. So that distance you are getting as 20 mm. So from here you mark 20 mm like this, perpendicular to this new line at 90 degrees. You have this 48 degree line. From here you want to draw a line at 20 mm perpendicular like this, perpendicular to this line. You can draw that line. You want to draw a line perpendicular to this line like this, having length 20 mm. Now once you get this point, you can mark this dimension and this dimension like this, from here to here, from here to here, and here to here. Similarly from here to here, this distance and this distance. So that distance you mark here on this new line, here to here, here to here, and here to here. Now you can draw that line 60 this 20 mm. From here you mark that dimension like this, perpendicular like this, and this side, this dimension, half of this dimension. From here you mark this side, and half of the dimension you mark this side. Similarly from here you mark this 20 mm like this and like this. Similarly from here, this distance, half of this distance from here to here like this, here to here. Same way you draw here also, this distance you mark here, and the other distance towards downwards like this, and from here to here and here to here distance you mark here, and also half of this distance from here to here. So you'll get some 6 points. Connect those points, you'll get a hexagon like this, here and here. That means you are copying this diagram at 48 degrees, tilting at 48 degrees like this. Name those points as with suffix 2, that is 1 2 2 2 3 2 etc., and A2 B2 C2 D2 etc. Now once you get those diagram, you just draw the reference the projection lines from here like this, from all these 6 points here and 6 points here like this. Now draw vertical lines from all these 6 points here to the corresponding line, that is 1 2 to 2 2 1 2 to 1 2 dash, 2 2 to 2 2 dash, 1 2 to 1 1 dash, 2 2 to 2 1 dash, 3 2 to 3 1 dash, etc. here, and here also, that is A2 to A1 dash, B2 to B1 dash, C2 to C1 dash, like this, D2 to D1 dash. So you'll get 6 points here and 6 points here. Connect those line points, you'll get straight lines like this. You'll get 2 hexagons like this. Now the face which is coming towards the observer is here. So this is the front view. So the face which is coming towards the observer is visible here. So this face is facing the observer, and this face is facing the vertical plane. So the face which is facing the base which is facing the vertical plane will be invisible. So first you mark this face is visible. So first you mark the visible base face like this. Then you draw the border like this. Then you consider this diagram. In this diagram, the points which are coming inside bracket here. So here you have 1 dash, 6 1 dash, and 5 1 dash. So all the remaining lines to those points will be invisible. So here this one, and this one. So this line will be already in border. So this line is already border. So border will be visible. So after marking the visible face, you draw the border. Then you consider this diagram. In this diagram, whatever points are coming inside bracket, here you have 1 1 dash, 6 1 dash, and 5 1 dash. So here all those remaining lines to those points will be invisible. That means you have this one, that is 2 2 dash, 1 2 dash, 1 2 dash, A2 dash, 1 2 dash, 6 2 dash, 6 2 dash, F2 dash, and 6 2 dash, 5 2 dash. All those 5 lines will be invisible. The remaining lines will be visible because that is border. Now you have 2 more lines remaining, 3 2 dash, C2 dash, and 4 2 dash, D2 dash. Those lines will be visible. Now finally you can draw the axis to get a 3-dimensional appearance. To get the axis, you draw lines from one corner to opposite corner, and another corner to opposite corner. Meeting of those 2 lines will give you a point here. Similarly here also, top face also, you draw a line from one corner to opposite corner and another corner to opposite corner. Meeting of those 2 lines will give you another point. Connect those points here like this using a chain line. So that is the axis. That's how you draw the projection of a hexagonal prism with axis inclined, both axis inclined to HP and VP. Hope you understood this diagram. Please like this video and please subscribe for getting more such videos. Thank you very much.